Yeah, guys, you can start.
Hi, my name's Amelia, and I'm part of the Electric Zombies, a team of 6 that worked on a data science project. Over the past 3 weeks, we built a website that predicts a user's salary based on various inputs like occupation, education, work class, race, and age. So, what is our website really about? Our website is a predictive algorithm that takes in user input and compares it to graphical data that shows the correlation between education, occupation, and salary, and predicts whether someone's salary will be more or less than 50K based off of the given information. When coming up with our project idea, we realized that the majority of high schoolers and even some adults have no idea what they want to pursue as a future career. We've all been at crossroads when it comes to what we want to pursue, and that's why we built our AI model. We hope that our AI can help provide users with a clear path for their future endeavors. Essentially, our goal is to guide users to their future career path based on what they wish to accomplish with their education. So, is our data classification or regression? Classification refers to a binary data set, aka off or on. Regression refers to data that cannot be classified as binary, usually numerical or quantifiable data. Our set is classification because this AI categorizes the data to be either over 50K or under 50K. The dataset shows the correlation between education, occupation, age, and salary, and predicts whether someone's salary will be more or less than 50K based on the given information. What is our minimum viable product? Our MVP is a prediction site that provides users with information in regards to their salary. The dataset shows the correlation between education, occupation, and salary, and predicts whether someone's salary will be more or less than 50K based off of the given information. I will now be passing it on to my teammate, Adam.
Hi, I'm Adam. So data cleaning, and I'm going to be talking about data cleaning, is the process of preparing data for future analysis by changing or removing data that's incomplete, incorrect, irrelevant, duplicated, or improperly formatted. This is important because data cleaning ensures quality of the data set and provides better accuracy in its predictions. If data is not cleaned thoroughly, the accuracy of a model may be negatively impacted. For example, let's just talk about healthcare. Clear, more concise records can help speed up a patient's diagnosis. The data can also ensure that effective medication and treatment precision, as everyone needs a medical record. Moving on, the 3 main ways we cleaned our data was by removing unwanted columns, changing null values, and encoding our data. Before performing any data analysis, we removed unwanted columns since real-world data typically contains too much noise and only a few columns provide useful information. Another issue with real-world data is that it comes with gaps in the data, which are called null values. We treat this issue by imputing the null values with the mean, median, and mode or nearby values. Now we solve the 2 main issues. Our numerical and categorical data are required to be encoded, as machine learning only understands numeric data. These categorical values are encoded to zeros and ones, making them recognizable to machines and for our progs to work. I'll now be passing it off to my teammate, Aaron.
Exploratory data analysis. So why is it important? Because it finds all the data before coming to any assumption. So there's no personal bias. It's just numbers. It's just how it just shows how it is, and that's what's great about it. So let's take a look at the first graph, gender distribution. It shows the correlation between each gender, the male and female. And as you guys can notice from the graph, male overwhelmingly has a higher percentage than a female to their female counterpart. Now there are very complex variables. It's not simply just because how it's just how it is. There's certain things in life that just like have certain variables, like certain workforces, like architecture, carpentry. Those kind of workforces require a lot more people involved than, let's say, a teacher or a therapist, which communication jobs are more common among women. Um, so what this and then as you can see from the graph, and what's interesting about this graph, and I wouldn't be able to tell you why, is that under 50K, female has a 38%, but it drops significantly once female goes over 50K. I don't know how, that's just how it is. Let's take a look at the second graph, gender pay gap. So this basically shows whether or not higher number of education years determine a higher salary, which in short it does. But what's interesting is on average, women have to do a lot more education years in order to make the same amount of money as men. You can see here 12 to 11 years for women, and then 10 to 9 for men in order to make a good amount of money. This may be because certain occupations that common women that have education or which is common, is like doctors, nurses, and teachers. Those kind of things require a lot of years in order to even to get the right skills and such. Let's take a look at this next graph, race. So as you guys can tell, oh, if it loads, there we go. As you guys can tell, there's one glaring one. It's the one in the middle, and that's the Asian Pacific Islanders. They, on average, have to have more educational years in order to make the same amount of money as the race counterparts. And this is this is not really all accurate because of such a large sample size. Because even though they might have a couple figures that are making a lot of money, they also have a lot of people that don't make a good enough money. So as a result of that, it fluctuates and makes the whole graph skewed. Yeah. Next point, age distribution. This is probably the most, if it loads, but it's the most important aspect to any workforce. It's experience. And typically, the older you are, the more experience you have in that certain mastery, certain skill over that. I'm sorry, excuse me. But it's a huge part of the work field. And this doesn't really take to consider like outliers like athletes who make a lot of money despite being very young. This is just the overall average of how it is, and just the trend of how it works. And let's move on to the next point, higher education. And you guys can see here from the graph yourself that nothing is guaranteed in this world, but it increases the likelihood of, depending on what education you get. You can take a look at bachelor's. Bachelor's has a 28.3 to make over 50K, while only 12.7 make under 50K. So nothing is guaranteed. You can take 15 years of education, doesn't matter. It just increases the likelihood of succeeding into a better opportunity. You can take a look here, master's 3.52% at under 50K, while over 50K is about 12.2. And you could be successful as a high school graduate, but the probability of that happening is very unlikely. And then finally, to the heat map. And simply what this shows is it shows the importance of each variable into for it to succeeding. Like a salary over 50K, it shows age, education numbers, hours per week, but the most important of them all is education number, as it has the highest number. It has a 34% chance or for it to matter. And I would like to pass to my teammate Shellene.
Okay, so for my part, basically for solving any machine learning problems, we need to follow certain steps, from acquiring the data all the way to actually building the deep learning models. As a whole, this process is called the machine learning pipeline. So for the first part of this, it's basically feature engineering. It's a process of selecting, manipulating, and transforming the raw data into features to be used for supervised learning. With data validation in the works, the accuracy and quality of our source data improves significantly. Next is to test, train, and split. This step's ultimate function is to estimate the performance of the machine learning algorithms to be applied to prediction-based applications. We split the data into two parts, training data and test data. As the names imply, training data is to train the learning model, and the test data is to evaluate and test the performance of this model. Next is the encoding. Since real-world data contains both numerical and categorical data, the categorical columns are required to be encoded in order for the computer to be able to understand it, as it is not able to process non-numeric data. These inserted values are encoded to zeros and ones. Then, finally, it is time to build our models. We build 3 for our data: logistic regression, random forest, and neural network. These models are used to classify our data. We then compare the 3 models to find the neural network provided the highest accuracy result with an 84% accuracy. This model is ultimately the one that handles the predictions. Next, I'll be passing along explaining models to my teammate Joshua.
Hi, sorry about that. Hi, we have out of all the models that we could have used, we used three that we used to graph our data. The first being logistic regression, which is a method used to predict a binary outcome such as yes or no, based on prior observations of a data set. A logistic regression model predicts a dependent data variable by analyzing the relationship between one or more existing variables. In logistic regression, an S-shaped logistic function is used to predict two maximum values, either 0 or 1. The curve from the logistic regression function indicates the likelihood of the occurrence of each data piece. This chart down here is our confusion matrix for logistic regressions, which shows the actual values and the predicted values of that logistic regression had. We had an accuracy of 82%, a precision of 0.87, a recall of 0.90, and an F1 score of 0.88. Our next model, random forests, uses a sequence of decision trees that perform classification or regression by asking true or false questions. These then get solved with a majority vote. Each tree makes a class prediction, and the prediction with the most votes becomes our model's final prediction. By using uncorrelated trees who give individual outputs, the random forest model generates a prediction by the committee that is more accurate than any individual tree. This is the confusion matrix for random forest. It's pretty much the same thing as logistic regression, except it has different values. We had an accuracy of 82%, a precision of 0.87, a recall of 0.90, and an F1 score of 88. I'll now be passing on to my teammate, Karen.
Thank you. Okay, so I'm going to be talking about the last model that we use, which was neural networks. So neural network is a method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. It is a type of machine learning process called deep learning that uses interconnected nodes and neurons in a layered structure that resembles the human brain. Some projects that use neural network today on a daily basis include weather forecasting, credit scoring websites, and fraud detection systems. So for our accuracy score, this one actually scored the highest compared to logistic regression and random forest with an accuracy score of 84%. It had a precision of 0.87, a recall of 0.92, and an F1 score of 0.90. So down here we have our classification matrix, and basically these are what we used to evaluate the three models that we had, which were logistic regression, random forest, and neural networks. And finally, for our salary predictor, basically an individual can input a number of personal attributes such as age, education, work class into the system. The input is later sent to the model, which in our case was neural network since it had the highest accuracy score. And once the input is sent, it provides an output to users on whether their personal attributes would allow them to have an income greater than 50K or less than 50K. I will now be passing it on to my teammate Amelia to conclude.
To conclude, after analyzing our data, we found that out of all of the classification models, neural networks work the best for predicting salary. Our logistic regression and random forest models both had an accuracy of around 82%, while our neural network model had an accuracy of around 84%, making it the best of the three that we used. From the analysis, we can conclude that there is, in fact, a relation between level of education, age, race, and income received by a person. However, there are still ways for us to advance our predictions. We can better improve this machine learning model if we have more diverse data and also more data points. We hope that our model can help people make more informed decisions about their future. Thank you for listening.